Sound check, 111. Hello, everyone. Loud and clear. Good morning. Hey, how many of you can identify yourself with this picture here? Troubleshooting machines on your day-to-day operations. Show me your hand. Come on. You all got managerial so fast. Let me redo that question. Light on the audience real quick here. You probably forgot where you started. So, how many of you have ever had to do this when you were starting your career? Show me your hand. Much better now. Yes. This is the reality of many of you, and this was the reality of my father. 35 years in a paper mill, started right there from the bottom, maintenance technician. The company paid for his educations, electrical engineering, and then going all the way up. But this is the reality. When a machine goes down, what do? Generally, you call the guy. And the guy being those three letters here, OEM, the original equipment manufacturer. And many of you here are from or work for OEMs, and it's nothing personal. It's just the way that the industry operates, that this data is proprietary or sometimes considered confidential on how to maintain your own equipment. So it's confidential that your air compressor has a Tinkin bearing inside or an SKF bearing. And you struggle to get this data, and a lot of your time and your technician's time are going into that troubleshooting. There are a lot of alarms out there saying, hey, something is wrong, go and check. And that go and check is biting your reliability program's time. And it's not a coincidence that this data is hard to get. This is by design. We have many instances of this happening as we speak right now. Machine goes down, we try to troubleshoot the air compressor, the motor, the engine, the gearbox, call the OEM. OEM says, hey, this is proprietary, I need to go there to your facility, need to check, we cannot give you that Tinkin bearing code so that you give to your supply chain and get it done with. And I took that from listed OEM companies, and of course, hide their names there, but on the left, you have one of major air compressor OEM companies, on the right as well, and you see that upper part of the pizza chart, almost 50% of that revenue is services. It's not a coincidence that selling equipment is less attractive than selling you the service to maintain that contract, to maintain your machine. So 5 years ago, when an asset went down, and this is a part of a Siemens study, when an asset went down, we took about 49 minutes to get it up and running back again. Do you think today is less or more time to get it up and running? Who think it's less? Show your hand. Who think it's more? Wow. I might be biased here, but you guys are pretty good. Yes, today it takes 81 minutes to take it back up and running, and that's related to how complex the machines got from the OEM, labor shortage, lack of skilled labor, and that all of those things combined, the reality is it's taking more time to get it up and running and not less. And that is a problem because labor shortage has been at an all-time high in America. That's not news to you, but you feel it on your skin right now. 100%, this is data from the US Chamber analysis, and this is really recent. Out of 100 jobs that you're posting on your manufacturing plant, you can only fill 73 of those. There's a 30% gap there. There's another way of reading this chart as well, because this is only getting worse and worse and worsening over time, is that you need to produce the same things, or are we producing less? Either you're producing the same at your plant, or you're trying to produce more. So that means that you need to get 30% more efficient to account for this gap. Your technician needs to be 30%, efficiency, probably not the right word, but productive. They need to have a better decision-making process to account for that huge gap that we're creating. And this is the problem, summarizing here. I mean, why is this happening? There's senior skilled labor retiring. Just look at this room here. Like, we're failing to attract younger generations to enter the workspace. That's a fact. Who's going to come to do that job? There is the OEM dependency of information and the newer generation retention span. You might not have TikTok, maybe some of you do, but this is having an impact right now as the younger generations, how they retain knowledge. They cannot read troubleshooting manuals anymore. And you're going to say, I don't care, just fix it, or are we going to enable that new generation to make decisions? And that it's obviously translating into money. Precisely the GDP of Spain is the amount of revenue that we're losing due to this lack of information. I say information, not data, because data you have on billions of data points, right? Some of you say we have billions and billions of data points, but how are you translating that into information? That's the real question. So the whole goal here of the next years of solutions is basically to decrease that human-to-machine knowledge gap. This is the biggest trouble and biggest issue for your reliability program. And at Tractian, we're trying to do just that. And you see, the future might look still a little bit rough, a little bit intangible of how you're going to do with all that technology coming in, the large language models, how you're going to translate that ChatGPT into your actual workspace, how you're going to embed that there. You all have many questions related to that. There was a boom and spikes, and now it's coming back to normal, and we're trying to use that information and what we can do with that. And it starts with the manuals, the data sheets, or maintenance log. You need to enrich your decision-making capabilities. So essentially, when we are comparing your condition monitoring system nowadays, there's basically 3 categories of condition monitoring, and you probably have one of those categories here already. The first one, hardwired sensors, it's called the green, yellow, red. A famous plant manager once said, just show me green, yellow, red. And that's what majority of your plants are showing. Green, yellow, red, there's 40,000 alarms there. Your technicians don't know what to do. To a point that your condition monitoring sensors sometimes even generate more clutter than not having it at all, than just hiring monthly inspectors and give you a PDF report. That's the reality. Then there's second-gen systems, so they automate the generation of thresholds for you. You don't need to do it manually anymore. You're automating the generation of friends, but you're still doing the manual root cause analysis yourself. And there's third-gen systems, which Tractian and some others are trying to do here, essentially automating the thresholds, supervising the diagnostics, but also going one step further. How do we automate the root cause analysis by looking at inside the data sheet of your equipment to help you troubleshoot that? I took this cloud of information here, and I try to make an example with our day-to-day, just regular lives. For example, think about a Tesla. You're driving your Model S, and suddenly an error code pops up in your screen. app_W207. If you go right now, and you can test it right now, just ask ChatGPT, what is that error code? It's going to reply something generalistic, or, sorry, we don't have access to this information, because those large language models are trained on public available information. It is, again, a mismatch. That information is available in some of your OneDrive, your document management, inside your SAP, or sometimes not available at all. and those models cannot consume that. So just taking that dummy example, when we actually open Tesla's manual, you can see the error code right there. It's just like there's a list of error codes, and what do you do with that? In this case, related to poor visibility due to rain and etc. So when you feed that into our Copilot, essentially, and upload the manual, without a question, you're going to have, hey, that's what the APP alert is related to. Now, the question is, how do you make that systematically so that it makes sense to maintenance and maintenance can benefit from that? Because your own team, you're not going to be able to collect all the data sheet that's available out there, so it needs to be a collaborative system, anonymized, where everyone is benefiting from that. And OEMs are not going to like it too much, I'll say that. Here, another example, when you look at the ChatGPT again and you ask, hey, how do I do a procedure of changing the barriers of my WEG W22? You're going to have a generalist tool list, and it fails to specify bearings code, fails to specify the grease code that you need to use. Many of you here implemented reliability programs where you need to make right your hierarchy inside your ERP, whether it's SAP or your EAM, Maximo. Sometimes you get all the way to the component level, but when the question is bill of materials, a lot of you will get stuck. How could you not? It's absolutely super difficult to do with the systems out there, or almost impossible. And that bill of materials part, not having that bearing code to transmit to your spare parts management, not having that grease code, it's consuming you a heck tons of time and money. So this, on the right side, is an example generated by Tractian when you ask the same question without feeding in with any data sheet information whatsoever. You put the serial number of your motor there, and boom, those are the bearing codes that you need to replace, and this is the grease that you need to use. So I really like this phrase here, which is, we're all doing the right things. We're all thinking we're doing the right things. The question is, how do we enhance our decision-making capabilities so the observe, orient, decide, and act, which is called the OODA loop, it's not a framework, it's a concept, and it's happening right now. It's happening right now as I speak. It's happening right now at your plant. And we need to really study the science of how we decide to be able to operate better. Not only how we orient, but how decision-making is done. And the OODA loop is happening right now. As I see Maura looking at my face here, I'm rerouting, observing, rerouting, and deciding again. And decision is also interesting because omitting or not deciding at all is a decision. You're deciding not to decide on any specific issue or matter. The decision is done. So generally, to wrap up things a little bit here, how are you observing today your condition monitoring systems? And this is an example of how it's happening at majority of the plants that we see. There's a green, yellow, red. And that's the condition of asset health that you have showing and popping up on your screen, and you need to decide what you're going to do with that. Now what, right? The orientation phase. You need to really empower your technicians to decide better, but some of the times you're going to just say, hey, figure it out yourself. It's on you. You're paid to do this job. And inevitably, that's leading to a chain of wrong decision-making. Call the OEM, try to figure out. Call someone at the plant, let's look at that. And the troubleshooting and that threshold-based decision is costing you money. And thresholds do adapt as well and do change. So you might have a threshold there at your plant right now they're using for ages, but once you replace that bearing, that threshold is going to change. Essentially, that action is actually resulting in inaction or an incomplete snapshot of your systems. And systems are failing to adapt to your condition and your criticality matrix, essentially. So assertiveness It's a timely concept. It might not be assertive now, it might be assertive later. If you are at a pulp and paper facility, you might want to run your assets nominally. Stage 1 bearing fault, and you want to go there and change that bearing. If you are at food and beverage, you might want to extend a little bit further. It's all related to the cost of downtime. So how we recommend that being done? Observation. Observation is not a green, yellow, red. Unitary is a green, yellow, red in multi-state for different failure codes. You need to know exactly that, like we've seen in that picture before in that cool video from RDI, a looseness might cause a misalignment. That might cause an imbalance. So you have a little bit of both there, and you need to decide what to tackle. It's almost like submitting a cat picture to a neural network and receiving it. It's a 90% cat, 10% a dog, because those are intertwined. And then the orientation, where we are at the PF curve, the potential failure curve. It's necessary that you assess that. And you also look at the replacement asset value. It's just looking at maintenance log is absolutely critical, because otherwise you're maintaining, and you forget that the cost of maintaining that is bigger than the depreciation of the asset. Time to change your asset. And then the side is enriching and connecting all those data points, your maintenance log, the manual, the data sheet, and trying to deliver a troubleshoot guidance for your technician. That's decision, and that decision needs to be empowered into the systems that we're using currently. And decision is a hypothesis. So decision needs to be iterative, and you always deciding and looping back to the system what you've decided, because that's absolutely critical. We might think, or we might have the certainty that the decision is something fixed, that's it, that's 8 or 80. You're just making a hypothesis no matter, right? And you might change that motor, open the bearing, and it was too soon. So you need to feed back the system to appropriately work for your criticality, the way you want to run the machines, and account for human errors as well. And then finally, acting. And if you shall leave IMC this year with just one thing in mind, I want you to think that quality of decision-making is our responsibility. It's not your technician's responsibility. It's not their job to just fix it, and your job to just do meetings. It's all our job to take care of reliability programs like you are in our asset health. Thank you.